Today we're going to wrap up our Unit 3 by talking about polynomial division. We've already seen sort of variations of division twice. Once when we talked about function operations, we didn't actually do any actual dividing, we just sort of set it up. And our other one was in our last set of notes when we looked at simplifying those rationals, because a rational, which is a fraction, is really division. And so if we can simplify using factoring, that's one way to divide. We can't always do that, and so that's what we're going to use our tools today for. So let's do a quick review of some terminology. So when we're dividing, we have the quotient. This is sort of what we normally call the result of division. Now it's not really the full result. This is like the evenly divisible part. When we're dividing numbers, this is like the whole number part. Our remainder is the leftover, what we weren't able to divide out, what we couldn't divide evenly. So let's look at like an example with numbers. So let's say we wanted to do 12 divided by 5, right? Well, there's a lot of different ways to do this. Let's do just the fraction way. 12 over 5, if we simplify that as a fraction, that is 2, because 5 goes in 2 times, 10/5, and then we have 2/5 left over, right? That's one way we might write it. If we do the long division way, 5 doesn't go into 1, but 5 goes into 12. Well, 2 times gives us 10, and so we get 2 remainder 2, right? That's another way we might write it. So we get our quotient, which is this part on the top, or our whole number part when we're working with just numbers, and our remainder, which is the leftover, what we weren't able to divide. And notice it's still divided by 5 when we write it as a mixed number. And so we can do something similar when we have polynomials. And so we have 2 different ways to write it. And so this first way, where we're working with fractions, is kind of like this mixed number scenario when we're working with just numbers. Then we have this way, which is more like a factored way, which is a little bit more like what we wrote up, especially in this top line of this example. And so we can either write it as a fraction, so let's copy that down here. If we write it as a fraction, f divided by g of x, so we want to know what the result is. Well, we're going to get our quotient, that's q. And then we need to add to that our remainder, that's r of x. Why is it r of x? Because it could be an expression. It's not necessarily just a number now. That's why these are all of x's. And that remainder, we did not divide by g of x, so it is still being divided by g of x. Some other terminology. F of x is called our dividend. It's what we're dividing. G of x is our divisor. Right. So we have a dividend, a divisor, a quotient, a remainder. We still have our divisor over here. Because remember, if we go back to this example, we could not divide that 2 by that 5. And so when we write it as a fraction, we leave it still divided by 5. The other way we can write this is to write f of x, basically factored. This is like a version of factored form. It's not really factored, right? Because we're not writing it as factors. We have that remainder. But so we're going to write q of x times g of x. So we have our quotient times our divisor. And then we have to add our remainder. And so let's look at what we really mean by the second one. We'll go back to our example, right? So we got 5 divided by 12 was 2, remainder 2. Well, that means is that 12 is equal to 5 times 2 plus 2. 5 times 2 is 10, plus 2 is 12. So that's what we're doing here. Whereas this one is our mixed number. If we do that over here, this would be 12 divided by 5 equals our quotient, which was 2, plus our remainder, which is 2, divided by our divisor, which is 5. And 2 plus 2/5 is just the mixed number, 2 and 2/5. So you will need to write your answer in one of these two solutions unless asked for a specific part, right? If I just ask you for the quotient or I just ask you for the remainder, let's actually change this to r of x, then you can just provide that information. Okay, so let's do some practice problems and learn how long division works for polynomials. So as we do this one, we are going to do a long division number problem at the same time. So let's do like 235 divided by, let's say, 2. So when we divide normal numbers, we just look at these two numbers first, right? We don't care about the 3 or the 5. And so in our polynomial, we're going to do something similar. We're only going to look at this first term, but we're also only going to look at the first term on the outside. So you look at the first terms only. Okay. Then when we're working with a normal number, we ask ourselves, how many times does 2 go into 2? Well, the answer would be 1. How do we know that? Well, we would do 2 divided by 2 is 1, and that's what goes on top. We're going to do a similar thing here. We're going to divide to get the number on top. 2a squared divided by a. Remember, it's always inside divided by outside. That's how it works when we set up our division. The inside, this is our dividend. This is our divisor. So what is 2a squared divided by a? Well, that is 2a. That's what goes on top. 2a. Let's go back to our original problem. Once we get here, we multiply 1 times 2, and then we write it down here. 1 times 2 is 2. So let's do that over here. We're going to multiply our number on top from here by, except this time we have not 1, but 2 things outside. So we have to multiply it by all. That means if there are 3 things outside, we multiply it by all 3. Multiply it by all terms in the divisor. So we have 2a times a, that's 2a squared. 2a times negative 2 is negative 4a. So that's how we get our line in the bottom. All right, so let's go back to our regular numbers. What do we do now? Well, we subtract. 2 minus 2 is 0. It's good, we wanted it to go away. So that's what we're going to do now. We're going to subtract. One way to do this subtraction is to just change all the signs. So this becomes a minus, this becomes a plus, and then we're going to combine like terms. Make sure you're combining like terms, not terms that are stacked on top of each other. They're not necessarily stacked on top of their like partner. Here they happen to be, which is nice. We get 2a squared minus 2a. Goes away. That should always happen. They should always cancel because we built it that way. Then we get 3a plus 4a. That is 7a. Then what we're going to do is pull everybody down. We also do that here. Normally we just pull down the next one. For polynomials, I would recommend pulling them all down because sometimes it's easy to get lost with terms. So I find it helpful to pull everybody down. So we pull down new terms. Pull down other terms. All right, so what do we do next? So now we do the same thing. We just like rinse and repeat, right? Except our first term is now here, right? Now we're looking at this 3. So we're looking at 3 divided by 2. How many times does 3 go into 2? It only goes in once, and then we have 1 left over, but we're going to put a 1 up here, right? So we're going to repeat now with the new first term. So we're going back to here. We're going to go back through our steps. So our first term now is 7a. We're still using just the first term out here. So we're going to do 7a divided by a gives us 7. Put that up top. 7. And it's going to be a plus because it is a positive 7. That's why we put a plus sign there. Don't forget your signs. Okay. Then we multiply times everybody on the outside. 7 times a is 7a. 7 times negative 2 is negative 14. That was this step. Right? Now we got to do our next one. Subtract. Change all the signs, combine like terms. Change our signs, minus, plus, combine like terms. 7a and negative 7 cancel. Negative 8 and plus 14 gives us 6. So let's sort of catch up here. We do 1 times 2, 2. We subtract, we get 1. Here we would pull this down and we get 15, right? Then we would keep going. Rinse and repeat. Our new term over here is 6. What's 6 divided by a? Whoop, can't do that. That means we're done. We can't divide anymore. Over here in our problem, we can do 15 divided by 2. That's going to get us 7 with a remainder of 1. So we put a 7 up here. Multiply, 14, subtract, and we get 1. We could keep going to get a decimal, but we're going to leave this because we don't do decimals when it comes to our polynomials. So we would be done. So let's now write it out. Let's identify our function, our divisor. Let's make some space. So we have our dividend, our divisor, our quotient, called q of x, and our remainder, r of x. So our dividend is the thing inside our division symbol. So that's 2a squared plus 3a minus 8. Our divisor is what's outside, a minus 2. Our quotient is on top, 2a plus 7. Our remainder is down at the bottom, that's 6. Let's highlight that. So our remainder was here. Our quotient is up here. Our divisor was on the outside. And our dividend is inside. Oh, let's use a different color. It's too close to something else. Let's use the purple. That's where we get all of those numbers from. Now we have 2 ways we can write it out. For this one, let's write it out both ways. So if we do f of x divided by g of x, that is 2a squared plus 3a minus 8 divided by g of x, a minus 2, is equal to our quotient, 2a plus 7, plus our remainder, 6, divided by our divisor, a minus 2. Please make sure when you write this that it is very clear what you're dividing. This looks like this. They are not the same thing. If you're going to write it like this, you need to put this in parentheses. Be very careful about how you write it. I will read it the way it is written, not necessarily the way you intend it. Let's write it the other way. So this is where we have f of x, 2a squared, plus 3a minus 8, is equal to our quotient, 2a plus 7, times our divisor, a minus 2, plus our remainder, 6. So either one of these is a valid way to write out our solution to this polynomial division problem. The more you do it, the more you get the hang of it, the easier this gets. This is really just long division of numbers applied to polynomials. That's all we're really doing. So we're going to do 2 more examples. In our next 2, we're just going to talk through the steps. I'm not going to write them down again, but you can always reference this list of steps to remember what we're doing. Okay. So this is our next problem. Let's go ahead and start our list. We want our dividend, which we normally call f of x, our divisor, g of x, and then we're looking for a quotient, which we're going to call q of x, and a remainder, which we'll call r of x. We can already identify our dividend and our divisor. Dividend is inside here. Our divisor is outside. So our dividend is x cubed minus x squared plus 2. So we're dividing x cubed minus x squared plus 2 by something. That something is what's on the outside. It is x plus 1. All right, so let's go through the motions. We're going to look at our first terms and our first terms only. X cubed and x. We got to decide how many times does x go into x cubed? Well, it goes in x squared times. It doesn't go in twice, it goes in x squared times. You actually need to do this division. X squared goes on top. What do we do next? Multiply by everything on the outside. Notice I said everything, not all 2 things. If there are 4 things outside, you will multiply all 4 of them by x squared. X squared times x is x cubed. X squared times 1 is x squared. Positive. Then we got to change the signs. Why are we changing the signs? Because we're subtracting. Minus, minus. Then we're going to combine like terms. These 2 cancel. They better cancel. Negative x squared and negative x squared is negative 2x squared. If you mess up your signs, then that would not be there, and that would be a problem. So now we get this. Do the same thing again. First term only. So we want to know how many times does x go into negative 2x squared. That means we got to do this division. That gives us negative 2x. That goes on top. Keep the sign. Negative 2x. Multiply. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is negative 2x. Change the signs. Why do we change the signs? Because we're subtracting. Plus. Plus. Combine like terms. Negative 2x squared, positive 2x squared. Cancels. 2 and x squared, not like terms. They don't combine. Make sure you are looking for like terms. If you're not actively looking for like terms and you're just combining numbers, you're going to mess up. This is 2x plus x. Look at our first terms. 2x, x. Divide them. 2x divided by x is 2. So we're going to have a plus 2. Make sure you take the sign. That goes on top. Now we multiply by everybody on the outside. 2 times x is 2x. 2 times 1 is 2. Change the signs. Minus. Minus. Combine like terms. 2x minus 2x goes away. 2 minus 2 goes away. We have 0. There's nothing left. There's no remainder. So our remainder is 0. Our quotient is that top bit, x squared minus 2x plus 2. All right, let's write it out. Let's do it both ways. Our first way is our sort of fraction way, where we have f of x, which is x cubed minus x squared plus 2 divided by our divisor, x plus 1, or g of x, is equal to our quotient, x squared minus 2x plus 2, plus our remainder, which is 0. And so what's actually happening here is because we have a remainder of 0, this is actually our fraction simplified. Let's write it the other way. So that's where we write f of x equals, so this is x cubed minus x squared plus 2 equals. If you don't remember where I'm getting these from, they're from these two boxes up here, which is also in this paragraph. We are currently doing this one. F of x equals g times q, our divisor times our quotient, plus our remainder. So let's look. So we've got our divisor, x plus 1, times our quotient. It doesn't matter what order you do these in, because it's multiplication. So this one looks like this. Then we add our remainder, which is 0. So it just looks like this. And look, this is factored now. So using division, we actually just factored a cubic that we would not have been able to factor before. We did not have a method for factoring this cubic, but using polynomial division, we actually ended up with a factored expression. That's one of the benefits to doing this, is it allows us to maybe factor things that we couldn't factor before. All right, let's do another one. This one's different. We've got a trinomial on the outside. We've got a big long quartic on the inside. So let's identify our pieces. Our dividend, that's our inside. That is z to the 4th plus 2z cubed plus 7z plus 3. We have our divisor. That's our outside, g of x. That's z squared minus 2z plus 6. And then we're looking for our quotient, which we'll call q of x, and our remainder, which we'll call r of x. All right, so we start, same process, it's always the same. Look at our first terms, okay? So we've got z to the 4th divided by z squared. So that's z squared, right? That's what happens when we simplify. That goes on top. Multiply. There are 3 things on the outside, so it gets multiplied by all 3. Z squared times z squared is z to the 4th. Z squared times negative 2z is negative 2z cubed. Z squared times 6 is plus 6z squared. Next, we change the signs. Why do we change the signs? Because we are subtracting. Change our signs, combine like terms. Z to the 4th minus z to the 4th cancels. 2z cubed plus 2z cubed is 4z cubed. Oh, not like terms. They don't combine, so we just write them down individually. Minus 6z squared. We want to make sure it's in standard form. Plus 7z plus 3. Rinse and repeat. First term. 4z cubed divided by z squared. It's going to give us 4z plus 4z. Multiply times every term on the outside. Doesn't matter how many they are, you're going to do all of them. 4z times z squared. 4z cubed. 4z times negative 2z. Negative 8z squared. 4z times 6 plus 24z. Change the signs. Why are we changing the signs? Because we are subtracting. Combine like terms. 4z cubed, negative 4z cubed, cancel. Remember, we should always expect those two to cancel. Then we have negative 6z squared plus 8z squared, 2z squared. So these inside terms are where we normally make our mistake because we don't change the sign. Make sure you change all the signs. Then we got 7z minus 24z is negative 17z, and then plus 3. Rinse and repeat. First terms, 2z squared, z squared. 2z squared divided by z squared is 2. plus 2. Multiply by everybody on the outside. 2 times z squared, 2z squared. 2 times negative 2z, negative 4z. 2 times 6, 12. Change the signs. Why are we changing the signs? Because we are subtracting. Combine like terms. 2z squared and negative 2z squared cancels. First term should always cancel. Negative 17z plus 4z is negative 13z. Then we have 3 minus 12 is negative 9. Okay. First terms. Negative 13z, z squared. Negative 13z, z squared. We can't do anything with that. So that means that this is our remainder. So our remainder is negative 13z minus 9. And actually, we should change all of these to z because that's the variable we're using, right? Not x. And our quotient, that's our thing on top, z squared plus 4z plus 2. So let's write it out. Let's do our 2 methods. Remember, these come from this box up here. So let's do our first one, this fraction one. F divided by g is our quotient plus our remainder divided by g. So we say r inside z to the 4th plus 2z cubed plus 7z plus 3 divided by z squared minus 2z plus 6 is equal to our quotient, z squared plus 4z plus 2, plus our remainder divided by our divisor. Let's actually move this guy. So our remainder, which is negative 13z minus 9, divided by our divisor, z squared minus 2z plus 6. So that's one way to write it. Oops. All right, let's write it the other way. So that's where we write f of x, our inside, 2z cubed plus 7z plus 3 is equal to our quotient, z squared plus 4z plus 2, times our divisor, z squared minus 2z plus 6, plus our remainder, which is negative 13z minus 9. So this is how we could write our solution to this problem. Sometimes we'll see questions where we're looking for a value and we can actually use polynomial division to find it. So we'll see problems that look like this. Find the value of k. Well, k is this coefficient here. Now it's negative, we're going to need to remember that. So that the remainder of x cubed plus 3x squared minus kx minus 24 divided by x plus 3 is 0. Well, let's set it up. So we're dividing by x plus 3. This is our divisor. This is what we're dividing by x plus 3. This is our dividend. It's our dividend because it goes on the inside. So we're going to put this inside. And then our x plus 3 goes on the outside. Then we got to divide. And we want a remainder of 0. Well, let's just go ahead and divide to our first terms. X cubed divided by x is x squared. Multiply by everybody on the outside, we get x cubed plus 3x squared. Change the signs because we're subtracting. This cancels and this cancels this time, so we're just going to pull everybody down. Negative kx minus 24. And we're looking at our first terms, negative kx and x. Negative kx divided by x is just negative k, so that's what goes on top. Multiply. Negative kx, and then we get negative 3k. Change the signs, plus, plus. Change the signs because we're subtracting. Combine like terms, cancel. Here we get 3k minus 24. Now realistically, this is a whole term because there's no x's. So 3k minus 24 divided by x, we can't do anything. So that means this is our remainder. So our remainder is 3k minus 24, but we want our remainder to be 0. So we're just going to set this, 3k minus 24, equal to 0, and then we're going to solve for k. Add 24, and we get 3k equals 24. Divide by 3, we get k equals 8. So k is 8. So if we have an 8 there, it means that we're going to be able to divide and get a remainder of 0. So how does this relate to some of the stuff we've talked about before? Well, we have these two theorems. Our first theorem, which directly relates to what we talked about in notes 3.2 and 3.1. If we have a binomial, x minus r. That should look familiar. That's directly from our notes. I believe it was 3.2. If we have a binomial x minus r, that is a factor of the polynomial f of x. If and only if p of r is equal to 0. We've talked about that before, right? And so what if and only if means is it goes both ways. If we plug r in and get 0, then we can say x minus r is a factor. And if we know x minus r is a factor, it means then that when we plug it in, we should get 0 back, right? So what this is really saying is if we plug in r, the corresponding solution, we get 0 back, right? Or we could say the function value at r is 0. Remember, we're looking for the corresponding solution. We don't plug in negative r, we plug in r. Right? We do have to make that distinction, and we've practiced that a couple times. And so this is called the factor theorem. So this actually directly relates to what we just did before and something called the remainder theorem. So what this says is if polynomial f of x is divided by x minus r, the remainder is a constant, like 3, a number. We're going to make this line a little bit longer than it is. The value of the remainder is p of r. Let's reword that. So what that really means is that the remainder, when we divide by something like x minus r, is the function value. So one of the benefits is we can check by plugging it in. it gives us a good indication if we did our division right. It also lets us check if it's a factor, right? Because it should be a factor if we get a remainder of 0. That's how these two things sort of relate. So it's a factor if there's a remainder of 0. We've talked about that before with numbers. So if there's no remainder, it is a factor. All right, so let's see this actually like in action. In number 1, we want to find the value of k, so the remainder of x cubed minus 4x squared plus 6x plus k divided by x minus 1 is 0. Well, let's use the remainder theorem. So the remainder theorem says if we plug in this solution value, right, so the solution would be 1. So p of 1 is our remainder, and we want the remainder to be 0, right? So let's figure out what the remainder is. We're going to plug 1 in. 1 cubed minus 4 times 1 squared plus 6 times 1 plus k. We get 1 minus 4 plus 6 plus k. So 1 plus 6 is 7 minus 4. That's going to give us 3 plus k. We need that to be 0. So this is our remainder. Notice we got our remainder without actually having to divide. This is going to be 0. So if we subtract 3, that means that k is negative 3. So we did one of those remainder problems, which took us a lot more work when we did division, but because we had just something nice, all we had to do was plug in our solution. Number 2 says, what is the remainder of 5x squared minus 3x plus 4 divided by x plus 4? So we're going to do something similar. What's the solution? So our solution, if we were dividing by x plus 4, we got to change the sign, would be negative 4. So what's the remainder? Well, we're going to plug it in. So we have 5 times negative 4 squared minus 3 times negative 4 plus 4. That's 5 times 16 plus 12 plus 4. So we got 5 times 16 plus 16, and we would get 96, and this is our remainder. So we can find remainders by just plugging stuff in. Let's do one more. So this time we want to find the value of k such that x plus 3 is a factor of f of x equals x to the 4th minus 9x cubed plus kx squared minus 36. Well, it's a factor if the remainder is equal to 0. Or when we plug it in, it's 0, right? Same thing. So let's plug it in. What are we plugging in? Remember, we have to find the solution. We don't plug in 3, we're going to plug in negative 3. So let's plug it in. F of negative 3, we get negative 3 to the 4th minus 9, negative 3 cubed plus k, negative 3 squared minus 36. All right, so negative 3 to the 4th, that is positive 81. Then we get minus 9 times negative 27 plus 9k minus 36. And we want this to be 0, right? It's got to be 0. Negative 9 times negative 27 is 243. So we're adding that to 81 plus 9k minus 36. All right, so let's combine like terms. 243 plus 81 minus 36. So we get 288 plus 9k is equal to 0. So now we just need to solve. We're going to subtract 288 from both sides. So we get 9k equals negative 288 divided by 9. And we get that k would have to be negative 288 divided by 9. The last thing we're going to talk about is synthetic division. Synthetic division is sort of a different way of talking about division. It's a way of looking at division with no variables. but we cannot always use synthetic division. That's important. Cannot use for all problems. We can only use synthetic division when we are dividing by x minus a number or x plus a number, right? So we cannot use when we're dividing by something like number x plus number. That would not be okay. Also, if we have x squared plus number, not okay. If we have a trinomial, any of those things are not going to work. It has to be like our simplest linear binomial, okay? To set up our problem, we have a little box here, and inside this box goes the solution, right? So if it's x minus a number, then the number goes inside. If it's x plus a number, then we put negative the number inside. We've got to change the sign. We've got to put the solution. On the top row, go all of our coefficients in standard form. And it is all of them. Then we are going to fill in this bit later, so we just leave it blank, like a blank line, and then we have this blank line. And then at the very end, we have a little box under our last term, and in here will go our remainder. And this will end up being the quotient. It's going to make more sense when we see it set up. But one thing to remember is that we have to include all of the powers of x. So that means if we're missing something, we need to make sure that we include 0 for any missing terms. We need to keep track of things that aren't there. So let's see it in action. So here we have a problem. We're doing x cubed plus 4x squared minus 3x minus 5 divided by x plus 3. So this goes in here, but we're looking for the solution. So we got to change the sign. Instead of positive 3, we're going to put in negative 3 in our box. This top line is our coefficients in standard form. Make sure you put the appropriate signs. What I like to do is put a little, we have an x cubed, so that means I need x cubed, I need x squared, I need x, and I'm a constant. Those aren't really necessary, but it sort of helps keep track of what's going where. So x cubed has a coefficient 1. X squared, that's a 4. X, negative 3, and our constant is negative 5. Now, below my constant, my last term, I'm going to draw a box, and inside this box is going to end up being my remainder. All right, so let's talk about the mechanics. How do we do this now? First thing we do, drop this. We don't do anything to it. Do nothing. Just copy. 1. Once we get that, we're now going to start a pattern. We're going to multiply negative 3 times the number down here. Negative 3 times 1 is negative 3. Then we're going to add 4 plus negative 3 is 1. We're going to do it again. Multiply. Negative 3 times 1. Put it up here. Negative 3. Add. Negative 3 plus negative 3. Negative 6. Do it again. Negative 3 times negative 6. That is positive 18. Watch your signs. Add. Negative 5 plus positive 18. Positive 13. So we have successfully completed our synthetic division now. Now we need to do something with it. We need to write out our answer. How do we do that? Well, we started with an x cubed, right? We got rid of an x. That means that we're going to have an x squared left. We go down by 1 power. Down by 1 degree. So instead of starting with x cubed, we're going to start with x squared. X squared, x, constant. Let's write it out with the coefficients. That would be 1 x squared plus 1 x minus 6. We don't really need those ones, so it's x squared plus x minus 6. This is our quotient. So our remainder is 13. Our quotient is x squared plus x minus 6. So let's write it out. We could write it like this: x cubed plus 4x squared minus 3x minus 5 is equal to our quotient, x squared plus x minus 6, times our divisor, x plus 3, plus our remainder. That's one way. We could also write it as x cubed plus 4x squared minus 3x minus 5 divided by x plus 3 is equal to our quotient, x squared plus x minus 6 plus 13 divided by x plus 3. Some people like synthetic division, some people don't. Synthetic division is kind of nice. It's kind of like solving by factoring. Nice when you can do it, but we can't always do it, which is sort of the disadvantage. Long division is like the quadratic formula. It always works. We can always divide using long division. Let's try another one. All right, so this one we're doing 2x to the 4th plus x minus 2 divided by x minus 2. So in our box goes the solution. So instead of -2, it's going to be +2. We just change the sign. So on our top row, we're going to go our coefficients. So we start with x to the 4th, and then we need all of the powers. So x to the 4th, x cubed, x squared, x, and then our constant. So x squared is 2. X cubed is nowhere. That's a 0. It's not there. X squared, don't have 1. 0. X, there's a 1 there. Constant is -2. Below our constant is going to go our box for our remainder. And if we want, we can go ahead and do this. We're going to go down in power, so instead of x to the 4th, down here it's going to be x cubed. Instead of x cubed, we're going to have x squared, then we're going to have x, we're going to have our constant, and then this is our remainder. You can put an r there if you want. First thing we do, drop it. Do nothing. Do not multiply. Do not pass go. Do not collect $100. 2 goes right here. Then we multiply. 2 times 2 is 4. We're going to add. 0 plus 4 is 4. Do it again. Multiply. 2 times 4, 8. Add. 0 plus 8, 8. Multiply. 2 times 8, 16. 1 plus 16, 17. Got a little off with my alignment. Multiply. 2 times 17, that's 34. -2 plus 34, 32. So our remainder is 32. Let's write our quotient out. We're going to have 2x cubed plus 4x squared plus 8x plus 17. This is our quotient. I'm just going to write mine out like a fraction. So we have 2x to the 4th plus x minus 2 divided by x minus 2 is equal to our quotient, 2x cubed plus 4x squared plus 8x plus 17 plus our remainder, 32, divided by our divisor, x minus 2. The other thing I like about synthetic division is takes up a lot less space, right? Our polynomial division took up quite a bit of space. It's a lot of keeping track of stuff. A little bit less. when we do this. So if I can do this, I tend to do synthetic division. All right, one more. We're looking in here, we're going to put it in the box. Change the sign because we're looking for our solution. Put in a 1 in the box this time. First row, these are our coefficients. Remember, we got to do all of our powers. I like to write them out. So we need our x to the 4th, our x cubed, x squared, x, and our constant. Remember, these x's don't really mean anything. They're just sort of a way to keep track of stuff. Below our constant goes our box for our remainder. All right, let's write down our coefficients. X to the 4th is -3. X cubed is 2. X squared, there isn't one. We do need to include that 0 though. X, -1. Constant, 1. We can go ahead and copy our powers down. Remember, they're going to be 1 less. So instead of x to the 4th, down here we're going to have x cubed. Below x cubed, we're going to have x squared. It's going to be x. It's going to be our constant. And then our remainder right here. First thing we do, copy it. Do nothing. Just rewrite it. Then we start to multiply. 1 times -3, -3. Add our rows. 2 and -3 makes -1. Do it again. Multiply. 1 times -1, -1. Add 0 and -1, -1. Multiply. You don't need to write these arrows. I'm just writing them so that hopefully you can follow what we're doing. 1 times -1, -1. -1 plus -1 is -2. We've got to multiply one more time. 1 times -2 is -2. 1 plus -2 is -1. That's our remainder. So let's write out our quotient. So we're going to have -3x cubed minus x squared minus x minus 2. That's our quotient. Let's write this one the other way. So we have -3x to the 4th plus 2x cubed minus x plus 1 is equal to our divisor, x minus 1, times our quotient, -3x cubed minus x squared minus x minus 2 plus our remainder, which is -1. We can also use synthetic division to help us solve those k value problems. So let's do one of those, and that'll be the last thing we do on these notes. So we're going to use synthetic division to find the value of k, so that the remainder of this division, 3x to the 4th minus 4x squared plus kx minus 10 divided by x minus 2 is 10. All right, so we got to set it up. We have our little box, and then our line. Inside our row box goes the solution to this, so it's going to be a 2. Then we need all of our coefficients, x to the 4th, cubed, squared, x, constant. So this is a 3x to the 4th. We don't have an x cubed, a minus 4x squared, kx, and a -10 as our constant. So this is going to be our remainder, and we want this box eventually to be 10. Okay. So let's just see what we can do. Drop it down, that's going to be a 3. Now we got to start our multiply. 2 times 3 is 6. We're adding. 0 plus 6 is 6. 2 times 6 is 12. -4 plus 12 is 8. 8 times 2 is 16. 16 plus k, well, that's k plus 16, right? Times 2, we got to multiply, so that's 2k plus 32. We just multiply those things by 2, right? Then to add these, we just combine like terms. We get 2k, and 30 and -10 is 22. But that has to be 10, so 2k plus 22 is going to be 10. So now we can solve for k. Minus 22. We get 2k is equal to -12 divided by 2. K has to be -6. So that's all of our polynomial division. We're going to spend some quality time practicing this together in class.